Okay, so this is review for integrated 3, semester 2, final countdown number 4. And this is dealing with a lot of polynomials in this section here. So let's take a look at the first one. So on this problem, they're asking us for the degree of the polynomial. And when it's in this factored form, okay, what you're going to do is you're going to look at each of the powers. That's 2. This is really a power 1. And then this is a power 4. And what you're going to do is you're going to add those powers together. 2 plus, again, that's really a, let me do it in a different color. It's really a 1 there, okay? So 2 plus 1 plus 4, that gives me 7. That would be degree 7. Now, a quick note. On one like number 13, which is also a polynomial, but it's not in the factored form, this is multiplied out, you would take the biggest power. So this one here would be degree 3. Okay, but when it's in a factored form, you don't take the biggest power, because all of those x's are going to multiply to give you that front power. So we need to add the 2, the 1, the 4, and get our final answer. Okay, on number 12. So on this one, we want to figure out where it bounces. So just a quick reference. If you have something that goes straight through, this would be degree 1. Okay, so here, let me draw it like this. I'm just going to draw a line for my imaginary x-axis. Okay, so let's say that that's my x-axis. Okay, so if I have a situation where I have an x-intercept and the graph goes straight through like this, that is going to be degree 1. If I have, and let me here kind of extend this out a little bit. Okay. If I have a point, and I don't care what direction it comes from above or below, and it bounces back, that is going to be an even degree. Okay. So it's going to be an even degree. So usually degree 2, but a degree 4 or 6 and so on would also do it. But again, normally a degree 2. If I had something like this where it goes through, but it doesn't go straight through. It kind of goes like this, like an S or like a snake, like a cubic graph. This would be an odd degree. Okay. Again, if it was a 1, though, it would go straight through. It'd be like my purple one. But if it was a 3, a 5, a 7, it's going to look like the pink one. Okay. So they want to know, where would it bounce? So the bounce is going to occur here. Okay. Again, this one here and this part here would look like the pink, where they're going to be curved and go through. The square is going to look like the orange in my graph below. So it's going to bounce at 6, 0, because that's what makes that 0. That's where it is. Okay, on number 13, we want to find the sum of the roots. So we want to be careful. They don't want us just to find the roots. We then want to take the sum of them. Okay, it doesn't mean we do the problem different. It just means at the end we have to add them up together. So the number at the end is our P. And so all the factors of 10 would be my P's. Plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. And all of the factors of the number in front, which happens to be a 1, would be my Q. So my Q would be 1. But since Q is just 1, when I do P over Q and I put all these over 1, I still get the same values. Okay. So now what I'm going to do is I am going to do synthetic division, and I am going to make it in a table form because I may not guess it right the first time. So you want to make sure you have it in descending order and you're not missing a term. So it is in descending order. I have my cubed, my square, my x, my 10. I'm not missing anything. If I was, I'd have to make sure I put a 0 to save its spot. So I'm going to write my coefficients: 1, -6, 3, and 10. And I always kind of take a look at this last number here. because as the last number here would be like my y-intercept. This is when my x is 0, I'm 10 above the x-axis, just so you kind of see where you are. Okay. So now I am going to try 1. I usually try 1 unless I notice that all of these are positives. If all these were positives, I'm not going to try any positive because they're never going to cancel out if I'm adding positives to a positive. But I do have a negative here. So I'm going to start with 1 and let's just see what happens. So I'm going to bring down my 1. 1 times 1 is 1. I add it to -6. I get -5. -5 times 1 is -5. I add it with 3. I get -2. -2 times 1 is -2. I add it with 10. I get 8. So right now I'm only 8 above, sorry. I was 10, now I'm 8. So I'm getting closer. I'm going to try 2, which is the next number. Okay. I don't like to jump to 5 because maybe I'll miss something. Okay. So let's kind of see what happens. So I'm going to bring down my 1. 1 times 2 is 2. I add it to -6. I get a -4. -4 times 2 is -8. I add it with 3. I get a -5. -5 times 2. Okay. This is going to look good. -5 times 2 is a -10. And I add it with 10. I get 0. So this is going to be my first root, my first solution. Okay. So I have x equal 2. So now I'm going to take this x squared minus 4x minus 5. Okay. It's going to be 1 degree less than we started with. And I can solve that. That's factorable. What multiplies to -5 and adds to -4? -5, +1. So I'm going to get x is equal to 5 and x is equal to -1. So now I've got 5 and -1 and they wanted a sum. So I'm going to add 2 and 5 and a -1. So let me just go -1. And so I get 7 minus 1, 6. That is the sum of my roots. Okay, my roots were 2, 5, and -1. Those were my solutions, but they wanted me to add them. And when I add them, I get 6. Okay, so on this one, I'm going to break so this one, they want us to give an exact polynomial. Okay, so that means we need to find our stretch, we need to find our A. I'm just going to kind of color code things. Let me code them to the same colors I did: pink, orange, okay, and purple. Okay, so pink is, so here I have a value, an x-intercept at -4. But if you look and see how it's crossing here, this is going to be a degree 3 because it's one of those cubed ones, okay, like this, okay, like that pink one, which is an odd degree, but the simplest one is always degree 3. So we're going to assume it's degree 3. Okay, so then as I'm coming over here, I then have another x-intercept at 0. And what happens here is it doesn't go through, it bounces back. And so that means that this is a degree 2. And then it comes and it goes through. So I've got it here at 3. Let me just write my 3. It goes straight through. So that means that's linear, that's degree 1. Okay. So in terms of my factors, I'm going to have y equal a. And then I have for my pink, that's going to be x plus 4 cubed. From my orange, the 0 would come from an x, but it's going to be squared. So because it's a double root, so x squared. And then the 3 comes from an x minus 3, and that's just a single. And then I'm going to take the point that they want it to go through, and I'm going to put it into my equation for x and y. So -3 is equal to a times 1 plus 4 cubed times 1 squared times 1 minus 3. So I'm going to get -3 is equal to a times 5 cubed, which is 125, times 1 times 1 minus 3, which is a -2. So now I'm going to have -3 is equal to, and when I multiply that together, I'm going to get a -250a. So my a is going to be 3/250. Okay, so now my final equation, I'll write it in black, is going to be y equal 3 over 250. And I like to put the x squared first. X plus 4 cubed times x minus 3. And that is our equation. Okay, on 15, okay, we want to describe the end behavior. So again, we want to look at what's happening here. So this is a degree 2, a degree 3, a degree 5. Okay, so what we want to do is figure out the degree of the polynomial. Now, if you have an even degree, an even degree, if it is positive, okay, if it is positive, I'll do positive and I'll do negative. And even positive is going to open up. So it's like a parabola. So it should be, well, so I don't want to say open up. It's going to be like a parabola. I think about parabola. So it's going to be up, up. And a negative even is going to be like an upside down parabola. So that means it's going to be down, down. Okay, my odd degrees, I think about them like a line. Okay, so if it is positive, a positive line would go start below and end above, okay, increasing. So that means it went down and then up. So this is going to be down, up. And if it is a negative one, what's going to happen is it would be a decreasing line. So it's going to be up, down. Okay, so we're starting above and then we end below. Okay, and the next situation is we have to figure out the degree. So we're going to take a 2 and a 3 and a 5. We're going to add those together, and that's going to give us a 10. And so that means we have an even situation. And if you look at the number in front, this is a negative, so I'm here. So my answer is, let me do it in, here, I'll highlight it. So this is my answer, okay? Because it is even, it's either going to be up, up, or down, down. Because it's negative, it's like an open down parabola. It is down, down. And that would be your answer. On 16, okay, so we want to figure out which of these this is. So what's going to happen is we want to know which one has the same value. Okay, so we basically, since all of them are cosines, we really just want to kind of pay attention to 33 pi 7s. Okay, so 33 pi 7s. The way I like to think about this, okay, is that if you are trying to figure out where you are in terms of a unit circle, and we don't have 7s as a nice value on the unit circle, but 7 goes into 33 4 times, which is 28, with 5 left over. Okay, so this is really 4 and 5/7 pi. So what does that mean? So what that means is if I am on a unit circle and I was to go by 7s, okay, first off, because of this 4, I am over here. This is always my even pies. The other side, I'll do it in orange. This is always my odd pies. This is always odd pi. Over here, this is always even pi. So if I have a 4, I know I'm going to go around, but I'm going to stop right here. That's where I'm going to stop. And then I need to go basically 5/7. And so I'm going to go 5 pi 7ths away. Okay, that's where I would be. So this one definitely would give me the same value because I ended up at 5 pi 7ths. Let's see if any others are. A negative 5 pi 7ths would have gone this direction to here, for example. And so that is not in the same, well, it's actually going to give us the same cosine. It will give you the same cosine because both of those cosines will be negative. So this one actually is going to work also. It's not in the same spot, but your cosine would be the same value. Okay, so let me get rid of that. Okay, so then if I'm looking at my 11 pi 7ths, okay, so 11 pi 7ths, this would be 7 pi 7ths. And I'm going to be going and 11 pi 7ths is going to end up being basically 4/7 beyond where I normally would be, which is going to be over here in this quadrant. So that's going to be a no. And if I do the negative of it, do that in orange, that would be me going this direction. I would end here, and that's a no. So the two answers would be those. Now, another way to approach this is you could try to figure out by adding and subtracting 2 pi's, like where you are. But again, you want to focus on it's not that you're at the same angle, it's that you have the same value for your cosine. And cosines are going to be the same in quadrant 2 as they are in quadrant 3. And they're going to be the same in quadrant 1 as they are in quadrant 4 if they're in the same location. Okay. On 17. Okay. So on 17, on this one, we want the phase shift. Okay, so the phase shift is what makes this 0. So I'm literally going to take this, set it equal to 0, and I end up with a negative pi 3rds. That's my phase shift. Okay, on 18, what is the period? So period is for sine, for everything but tangent and cotangent, is 2 pi over b. Okay, this is our period. And our b is the number in front of our x. So this is our b. Our b is pi halves. So what we are going to do is we're going to take 2 pi divided by my b, which is pi halves. Now, when I'm doing this, 2 pi divided by pi halves, I can change it to multiplying by the reciprocal. And so the pi's are going to cancel out. And I'm going to end up with 4. That's our period, 4. So on number 19, okay, I want to, so they're telling me that I'm in quadrant 2, okay, and I want to know what angle, well, okay, so our angles in quadrant 2, our sine is equal to the square root of 3 over 2. So on the unit circle, it is cosine of your angle, comma, sine of your angle. So your sine is your y. So I want short, long. I want my y to be the long. So that's where I am. And the coordinates here is short, but it's a negative because I'm going backwards in the negative x direction. So negative 1/2, comma, positive root 3/2. That is the coordinates of where I'm at. Now, location-wise, I'm at 2 pi 3rds, but I want the tangent from this angle. So tangent of an angle is equal to your sine over cosine or your y over x. So I am going to take my y, which is √3/2, and I am going to put that over my cosine, which is a -1/2. And I'm going to do that math. So I am going to take √3/2, and I'm going to times it by the reciprocal, so -2/1. Those cross out, and I get a -√3. And that would be my tangent. Okay, on 20, write the equation of a cosine with an amplitude of 5, period of pi/3, phase shift of pi, and vertical shift of -1. So this is going to be y = a cosine b x minus h plus k. I like to have my b outside. That way my phase shift is easier for me to write. Okay, they didn't say that it's like an upside down cosine graph or anything. So we're just going to assume that this is a +5 cosine. Now the b is going to come from the fact that our period is pi/3. So what I'm going to do, I'm going to take 2 pi over b is equal to pi/3, because that's the formula for period. So I'm going to get 6 pi is equal to b pi. So b is going to be equal to 6. So this is going to be 6. And then my phase shift is pi. So that's going to come from x minus pi. And then my vertical shift is a -1. So this is going to be a -1. And that is our equation. Okay, on 21, what is the amplitude of the graph? So I like to kind of draw in where my high is, which is at 7. Let me just write that here so I see it. And my low, which is at 1. Now, halfway in between is going to be my vertical shift. So you add them together, divide by 2. We call that average. So it's going to be 8/2, which is 4. So that means my vertical shift is at 4. Okay, so this is my vertical shift, which is 4. So my amplitude is how high above that I'm going. So I am or below. So I'm going 3 above, I'm going 3 below. So that means my amplitude is 3. Okay, on 22. Okay, so write the formula for the nth term. And looking at this, this looks like it's arithmetic. So I'm going to go a sub n is equal to 12, which is my first term, plus 5 times n minus 1. Done. That's your equation. That's it. That's how you would find any term in this arithmetic sequence. And that's the end of final countdown number 4.